and get started. Thank you, Dana, for recording this. We're so excited to have you all today. Take just a couple of seconds to drop a line in the chat about where you are joining us from. It looks like we've got from Alaska to Arizona, North Carolina, Alabama. We are so happy to have you all. San Diego, California, that's where I'm at too. Yay. Fantastic. We have a wide spread today. We've got a ton of amazing people, and I'm not surprised because we have a really fantastic topic. So we've got 64 attendees. We did have, I believe, over 200 register. People will be jumping on as we get started, but we will go ahead and do that. So again, we're so happy to have you joining us. My name is Jerica Owen. I am the Executive Director of the National Animal Care and Control Association. And we are here today to talk about bugs and all the cool things that entomology has to do with forensics specific to your role. So just a couple of quick housekeeping notes. Today's session, I believe, is an hour, and we will be saving time for Q&A. There's also Q&A throughout the session. If you want to use the Q&A function, please feel free to do so. We will get to as many of your questions as we can. If we need to answer some afterwards, we can do that as well. We are recording today's session, so if you would like to review it afterwards, it will be available on the Naca video resources library, which once you log into your member profile, it'll be available there. And at the end of the webinar, we are going to be doing a short survey. So we'd appreciate it if you could just take a couple of minutes to answer our survey, answer some questions, let us know what you thought, and it will really help us improve and plan for future sessions. And with that, I am going to go ahead and introduce our speaker. So today's speaker is Dr. Byrd. Dr. Byrd is a board-certified forensic entomologist with over 25 years of experience consulting on forensic casework. He has served as president of several professional organizations, including the American Board of Forensic Entomology and the North American Forensic Entomology Association. A published expert and editor for scientific journals, Dr. Byrd combines his academic background in entomology and forensic science to educate animal control, law enforcement, medical examiners, attorneys, and death investigators across not only the US, but also international. His research focuses on the behavior and development of insects relevant to legal investigations. We are so excited to have you with us today, Dr. Byrd. I know your schedule is very busy and keeps you very busy, so we're thankful that you made some time for us today. And I'm going to go ahead and hand it over to you.
Great. Thank you for having me. Very happy to be here and spread the word about forensic science, animal crime scenes, and in particular, my favorite, forensic entomology. So we had a little bit of technical issues with the Eventbrite website, but hopefully everybody can see my screen. Yes?
Yep, we can see it. Thank you.
Perfect. So this could be an entire lecture series of applying forensic science to animal crime scenes and why you should do it. Everybody here has probably been asked to participate in some type of an animal crime scene, and hopefully there was some legal investigation into that, because what we want to be able to do is to prosecute someone for a crime. When I was a graduate student within the CA Pound Human Identification Laboratory, and Dr. Maples was the state forensic anthropologist for the state of Florida, he would routinely do animal cases, and he got a little bit of grief from law enforcement and other administrators around the state, because he would have human cases in the lab under homicide investigations, and he would have animal cases. And it was somehow devaluing the human cases to also have animal cases in the lab. And his thought process and his firm belief was, doesn't matter if it's human and animal, a crime has been committed, and science will help bring the perpetrator to justice. So that's the mindset that I developed in as a undergraduate student and graduate student, and have kept with me through my entire career, and which is why I'm extremely happy to essentially provide my services for animal crime scenes if you have some entomological evidence. So you want to be able to prosecute someone for the crime. And in order to do that, you have to be able to give an attorney, and maybe someone's innocent and you need to defend them, but you have to give an attorney evidence. And that evidence generally comes from some sort of a legal jurisdiction, and that's often law enforcement. And if you're asked to come into a crime scene, then you're part of that evidence documentation process. So you may not have to be a boarded forensic scientist in any discipline to be able to help. There's plenty of training out there that is online and in person. Forensic photography is something that is critical and essential for every crime scene. And you don't have to be any sort of credentialed forensic photographer to be able to take good photographs of your crime scene. You just need some photography classes. If you can't find a forensic photography class, there are plenty at universities, adult education, lifelong learning. There's photography classes almost in every community. So in addition to photography, it's just basic documentation, legal documentation of evidence. How do you do that? And there's plenty of documentation in that as well. And then you come into other areas such as forensic entomology and forensic botany, for instance, where in order to make sense of that evidence, someone has to interpret it for you. At some point, you need an expert. But you may not need, and often you do not need, an expert in that discipline at your crime scene. You just need to know what to recognize and how to document it and how to collect it. So at some point in the future, I may be able to give you a nice overview of the use of forensic botany at a crime scene. Plants are everywhere, their seeds, their pollens are everywhere, and forensic botany provides evidence where no other type of forensic science can. And then there is entomology, which can also provide evidence where no other type of forensic science can. So what we're going to talk about today is the application of forensic entomology animal crime scenes, and it is a bit different than human applications, but not much. So I'm going to show you some animal cases and human cases, and we'll talk about their similarities and differences throughout. So first up is just to make my computer work, apparently, because it is not wanting to work. Stand by. Of course, we tested this a minute ago and it all worked very fine. Oh, of course. Let's restart our application.
Okay, we all understand how technology sometimes is super fun.
It works great until it doesn't.
So while we're waiting for Dr. Byrd to get this restarted, does anybody have experience with forensic entomology like he was mentioning? Has this been something that you all have been maybe had experience with? Just throw a quick little thumbs up in the chat if you have, just so we can kind of see. And then Dr. Byrd, whenever you're ready.
All right, so forensic entomology, what is it? Entomology is the study of insects. So an insect is any critter out there that's got, 6 legs essentially in 3 body segments. But we as entomologists kind of become the catch-all to a lot of other critters that you may find at your crime scene. Spiders, mites, and ticks, we will talk about that. They are not insects, but we often get involved with them. We become involved with marine environments, crayfish, crab scavenging, lobster scavenging, starfish scavenging on remains. So even in aquatic or marine environments, entomology or their related organisms can be pretty important. But officially, our definition that we've come up with for forensic entomology is the study of insects and their arthropod relatives that interact with legal matters. And not all of our cases are actually criminal. If you talk to forensic entomologists, a lot of our cases are civil in nature. Even with the medical examiner system, many are civil. Not going to be any criminal charges, but there are legal questions to be answered. So forensic entomology isn't new. I'll talk about this in all of my lectures because if you've been out in TV land much, most people remember the CSI television show, and that really got forensic science as a household name. But that wasn't the first public infatuation with forensic science. If you're older, and I'm not going to reveal how old I am, you remember Quincy M.E., the television show. So, and then before that, there was Nancy Drew and all of that. So each generation, let's say, has had their own fascination with forensic science, and it just goes on throughout history. So the way we practice forensic entomology now really started in the 1800s in France. But the first case that was documented of the use of an insect in a legal definition Is from 13th century China, and it's a great book. It's been translated into English several times now. But if you're interested in forensic science and death investigation, it's a good read. They talked about actually documenting penetrating injuries, some latent prints, and basically kind of a necropsy or an autopsy. And that was in the 1200s. So they were pretty advanced then. And unfortunately, we've lost some of that information as time has gone on and have had to redevelop it, particularly in European society. But forensic entomology has been around a long time. And really, what has gotten forensic entomology its traction was an attorney who used entomology in his cases. And he realized that the juror, the trier of fact, understood what the entomologist had to say, recognized entomology as a science, and associated with that, and that gave his case more credibility. And he was so enamored with how much credibility throwing science, particularly entomology, if he could use it, got into his cases. Um, he published an entire series of articles in legal journals, which made other attorneys aware of it. So then other attorneys started asking their legal investigators to bring this type of evidence to them. Those legal investigators really didn't know what to do with it, so then they started asking entomologists and biologists, and this is how really a lot of the fields of forensic biology came about. So, non-insects, spiders, mites, and ticks, all quite valuable, particularly with animal crime scenes, because a lot of these animal crime scenes may not be very clean. May surprise some of you, but in addition to all of the hoarder junk you may have experienced and the animals themselves, you may have probably walked into a spider web at some crime scene. So most all spiders have the ability to spin silk. Some do, some don't. Those that do may do it at particular times of the day. And just the creation of a spider web, if we know what species of spider made it, can give you timelines. So when you walk into that dark, dingy enclosure and you're passing through the a doorway or you're looking in the window, take note of that spider web. Take photos of it. Actually try to collect the web if you can. You can press it to paper and collect it. And if the spider is home, try to collect the occupant that built that web. May be able to use some civil and nautical twilight tables to determine when that spider went to work and when it was able to build that web to the stage of completion that you found it in. So spiders can be your friend. They do things. They do things at particular times, and that's often explainable. Genetics, DNA, has changed most every field of forensic science. It's certainly impacted forensic entomology as well. And this slide just reminds me to tell you about blood-feeding arthropods in general. You may think of like in the picture here, a common hard tick. Those are the broad classifications. You have hard ticks and soft ticks. You may think of a tick as something that would attach, feed for a long period of time, and then drop off. And that's true for some ticks. Some other ticks, particularly soft ticks, may feed for very short periods of times and drop off. And then you have mosquitoes and deer flies, horse flies, all of the tabanids, which take blood meals from multiple hosts. So if you see one of these organisms that is a blood feeder, you should probably collect it. And just like any other type of genetic analysis, the gut content can be extracted and a DNA analysis can be performed, and you might be able to recover the DNA of the animal or human on which it fed. And you might have admixture of multiple hosts. So particularly in human crime, if you've got the admixture of a human and a victim, say in a mosquito that is present at that crime scene, that creates a very strong link between that victim and suspect, and it then becomes hard for that suspect to deny that they were ever there. So keep in mind blood-feeding arthropods. They can link animals and people to scenes. And they may keep that blood meal for a period of time, sometimes days, weeks, or months. So if you're trying to pin activity to your crime scene and that activity may have occurred weeks or months prior, keep in mind that the insects that are buzzing around you or crawling around where actually at that crime scene, they may link to some past event. So this is where forensic entomology happens. It's actually carrion ecology. It's the decomposer community. And these decomposing insects are the insects that eat the detritus of decomposing vegetation, animal tissue, or human tissue. They've been around 350 million years at least. I mean, it's well documented in the fossil record, and really probably much longer than that, because the fossil record shows even that long ago, many of them are in a form very similar to what we see today, such as dragonflies and damselflies. Fleas, for instance, you may not know it, but fleas will jump. They also used to fly. That's what you might not know. So if you think fleas are a problem, imagine back when fleas had the ability to fly and disperse themselves. So trying to think of controlling your flea problem when they fly, strongly fly. So they did not have wings. Then they developed wings, and then wings weren't advantageous for them because it was kind of difficult to crawl through the hair of whatever was existing at that time, millions of years ago, and they de-evolved. They lost the ability to fly. So that type of ecology is boring to a lot of people, particularly law enforcement, but it's very interesting to us as scientists. And this care and ecology helps you in your case. And then what we have to do as forensic scientists is we take this very complex and complicated care and ecology, and we break it down into very simple terms. And the most common thing we're asked to interpret for a court is just how long dead. Um, so we take a lot of complex ecology, we break it down very simple, and then we go testify it in court. So part of the art of being a forensic entomologist is taking complex ecological processes and breaking them down um, very simply. So here we go. Depending on the entomologist you work with, you may get a report that talks about the time of death, or you may get a report that talks about the time of colonization. Those are very different things. Um, Most of the forensic entomologists I work with, when we get a report, it gives you a time of colonization. That is not the time of death. You want to know the time of death, and you may not be able to get there. And here's the reason. I mean, the time of colonization can be very close to the time of death. My record and all my casework, back when I was with the medical examiner's office, we had a traffic accident. It was 2.5 minutes. So 2.5 minutes from essentially death to being colonized by insects. That's a very short period of time. I've also had a research specimen and sat out in the field with it in the heat of summer for 3 days before the first insect showed up. So I now know, could be minutes to days. I don't know why. The difference is, but here's what happens. So an animal may die. How long does it take that animal to produce the odors of death that a fly will detect? You've probably been around animals. A lot of animals may have necrotic sores. They may have fetid fur. They may smell dead even though they're still alive. They may be colonized while they're still alive. Or there may be a healthy animal with no smell other than the normal smell that it may have while it's in good health. But how long does it take the tissues to start to decompose and produce an odor of decomposition that these insects can detect? We don't know. It depends on temperature, humidity, lots of environmental factors. Once they do start to produce the odors of death, how long does it take that fly to detect it? So once a fly sitting somewhere detects these odors, how long does it take them to fly around and locate that body? And then once they locate that body, how long does it take them to start to deposit eggs or larvae? So everything pre-colonization, we're not really that sure about. It's kind of one-off in this pre-colonization interval. We can guess, but you don't want to guess. You want to be right. So what we focus on is this post-colonization interval. That's when we can put these insects in a laboratory, rear them time and time again. We can put statistics to it, and we have repeatability. So that's what many forensic entomologists will give you, time of colonization. It's repeatable, it's provable. The pre-colonization interval, not so much. Um, so you can ask us, well, given the conditions, what do you think? And we may tell you what we think, but we're probably not going to put it in a report and go testify to it. So sometimes, the point is, sometimes we can give you a good piece of the puzzle that helps your case. And sometimes based on timing, the time of colonization may not answer every question that you need answered, but it's probably as good as we're going to be able to get with any reliability. And we would rather do that than be wrong. So that's my soapbox on that. Period of insect activity behavioral stages. I mean, we try to stay away from the adult fly behavior stages in a forensic report because we don't really understand it too much yet, but we're getting there. If you try to find a forensic entomologist, they're out there. You'll find a bunch. Probably one of the most common is an urban forensic entomologist. Probably doesn't help you in a medical legal investigation, but may help you if you've got termite damage to a structure on your property. But they're out there. Another type of entomologist you'll find is a stored product entomologist. dealing with insect contamination of food items. Plenty of those out there. And I do a lot of stored product cases, and we basically determine whether food contamination like this is accidental, whether it's allowable or not, because the government, FDA and USDA, will allow insect particulate matter in your food because it's economically infeasible to grow produce and produce food without there being some insect particulates. And it's not harmful to eat most insects. It's just kind of value added into your food, although some people may consider it kind of gross. So since it's not a health hazard, there are allowable limits of insect particulate matter in your food. Some of it can be quite significant. So stored product entomology is big business, but really what we're here today to talk about is the medical legal aspect of entomology. Some people call it medical criminal entomology, but not every case we get is a criminal case. Sometimes it's just a death of a human or animal. And some people want to know some questions about how long it's been dead, where it came from, was it transported, was it frozen, how was it treated, all sorts of questions. But certainly the most common thing we're asked to do is determine a portion of that postmortem interval. Cause and manner of death estimation. Sometimes we work with a pathologist because if you're dealing with a skeleton in the woods, there's no soft tissue. The distribution of insects around that skeleton can help tell where trauma may have been. And then that would help a pathologist or an osteologist or anthropologist look at those bones and try to figure out where the trauma may have been. Placement of body after death, movement of a body, particularly in animal cases where they may be wrapped or stored in a refrigerator or freezer before they finally deposited outside, put in trash bags. The shift of the insect fauna on bodies from attempts to conceal is often very apparent to an entomologist. We can tell you about that. Determination of death location, moving from one geographic location to another. Insects are often somewhat geographic specific, so we can often tell you where the body came from, or are they dealing with a secondary or primary crime scene. Criminal misuse of insects, particularly with children, and then abuse of children and elderly, and of course animals. That's what we're here today to talk about. So all sorts of applications of forensic entomology. Outside of the animal world, we'll get into traffic accident and air crash investigations with forensic entomology as well, because that is important. But for the most purposes, for casework, you can make a collection at a scene if you're properly trained, and you can do it just about as good as I could do it if I was there. And if you're interested in trying to, if you're one of these people that does animal crime scenes and you find yourself called into court and you're uncomfortable in court testifying about what you said and saw and done at a crime scene, the American Board of Forensic Entomology has a technician level certification now. You can take an approved workshop and get yourself a forensic entomology technician certificate. So when you go to court and they ask you, well, what qualifications do you have to collect these insects and how do we know you didn't miss the things that would exonerate my client at the crime scene because of your lack of training, you can present a certificate from the American Board of Forensic Entomology that proves or helps demonstrate to the court that you know what you're doing. You were trained by a professional entomologist. But point is, you do not need an entomologist at the scene. You can do it yourself. And the reason you can do it yourself is because you can recognize probably this is a fly. You can change its color and shape. You still know it's a fly and you know to collect it. Flies will lay eggs or larvae. They're very small, easy to overlook, but you don't need a microscope to see them. You can see them with the unaided human eye. And if you know what little eggs and larvae look like, you can attempt to collect them as well. Larvae of flies are called maggots. Larvae of beetle are called grubs. Grubs have legs. Maggots don't have legs. And all of them are going to feed on the body and then leave the body. They are designed to feed as rapidly as they can and then depart. And then they go to somewhere else in the crime scene to complete their life cycle. And their life cycle is the final stage in their, what we call their immature life cycle, is a pupa. It's analogous to the cocoon or chrysalis of a butterfly. That's going to be purposely removed from the body some distance, depending on the environment. And after a period of time, the adult insect is going to walk out of that casing. And generally, it's not going to recolonize the body that it grew up in as a maggot or a grub. It's going to go find another dead body, whether that be human or animal, to colonize. So if you can recognize the life cycle of a fly and you can recognize the life cycle of some beetles, you got this. Pretty much easy to collect and document. So here are some flies coming in. They're depositing their eggs. This is a gunshot wound. It is about a half hour post-mortem. Some of the blood is starting to coagulate, but notice where the flies are actually depositing their eggs. They are depositing their eggs very close to the site of trauma, but not in it. And that's one reason that forensic entomology is going to work for you. You don't have to open up the body and go dig into it to collect the entomological evidence. Most of it's going to be external. And the reason it's going to be external is in the larval stage, these little organisms still have to breathe air. So they're always going to be near the surface. Even in an extremely decomposed body, they're going to be under the surface. They may be under the body, but they're going to be where they can still get air. So you don't do any tissue damage to the trauma, to the body being able to collect them. So you create no trauma. So the rule is you photograph before you collect. Maybe you photograph during collection, not yourself, but the forceps or a gloved hand manipulating the insects. Then you photograph that area after to be able to prove that you haven't created any trauma. So it is external, and collection should be done at the scene just because the transport itself is going to cause some of these insects to fall off the body. You know, they don't have hands and arms, they can't hold on very well, and you don't want to lose any evidence. So if you can, make the collections at the scene before it gets to a post-mortem exam stage. If you can't get to the scene and the only thing you can do is a post-mortem exam collection, that's certainly better than nothing. So what happens? In humans and animals, it's the same thing. You have the same colonization pattern. So in the absence of trauma, these insects are going to go to the eyes, nose, and mouth first. They are going to deposit their eggs in hair. Female flies like to crawl through hair for some reason. I'll show you some pictures of some animals in a minute. And most animals have more hair than most people. So does hair and that fur coat alter your colonization patterns? Yes. Will it alter their growth patterns? Probably not. And they'll also deposit in folds of skin. Here's the thing that's very important for you animal folks who are trying to collect. There are excrement feeders and there are tissue feeders. In animals who have a fetid fur coat, the animal may be fine. I'll show you some pictures of this later. And some of the first insects may be feeding on the fur coat of a live animal. That animal may eventually die, and then another secondary species will come in and start feeding on the dead tissues. So it's two different timelines there. So if you're making a collection, if you're pulling these out of fur, you need to write down that you're actually getting them out of the fur itself. And if you're actually extracting them from tissue, you need to write down that you're actually getting them from tissue. There's difference. They're different species, different times, and that's very important when you're trying to work up your case. The exception to all of this that I just said is if there's trauma. If there's trauma, they usually will go to the site of trauma first. There's moisture there, there's sugar, free blood, points of access. So that's where these insects will tend to go. And then they'll ignore the natural body openings. So eyes, nose, and mouth. Nose is not usually deep into the nose. It's near the external nares, pretty easy to see, easy to collect. In the mouth, it's not deep into the oral cavity. It's usually where the lips meet the teeth meet the gums. And it's same in animals. So go to the eyes. Now, if the eyelids are closed, manipulate the eyelids. Open the eyes, look under. It's possible for these flies to deposit eggs on the cornea, and the eyes may eventually close as an artifact of decomposition. It encloses over those eggs or larvae. And then they're there on that eye and in that eye orbit to continue to develop, and you won't notice them externally until the development is pretty advanced. So manipulate the eye, look at all the folds of the ears, look around the lips and where the teeth meet the gums, and make your collection there. And also look into the nostrils. So it's going to be the same on humans and animals as far as that goes. Ears too. These insects will stay together. They tend to try to aggregate and make a larval mass. And so your larval collection should be from this area of maggots. What you do see is a large maggot mass here. And the reason I put in this picture is you see a lot of maggots here on the rest of the body, but they're not in the body. They're not eating. They're not developing well. So are they present? Yes. Should you photograph them? Yes. Should you worry about collecting them? You might want to get a sample or two just to prove you did it, but you want to collect from the area of active feeding maggots. And keep in mind this, the maggot skin is usually translucent. So what you're actually seeing is the fat body and some of their internal organs. And one of their internal organs is a crop. They have a crop just like a chicken would. And what you're seeing here is undigested tissues from the host. So if you need a DNA sample, you may want to select these maggots for your DNA. If you want a timeline sample, just collect a representative sample of the species you see. You want it to be representative as far as size, shape, and color. And if you want toxicology, then again, that should be a representative sample as well. So you may end up with maybe 3 different insect collections, one for DNA, one for toxicology, one for a timeline. That's fine. Keep them separate, keep them collected, and there's plenty of collection protocols on the internet as well and in many books. So during the heat of summer, this is the type of decomposition you usually see. They stay together, they will skeletalize the body in just a couple inches, then you have a fully fleshed body again. Same on the animal. So you may have decompositional changes, but what you're looking for are areas of tissue loss. So this is pretty specific, and the reason that you don't see any maggots still present is because we're now at a medical examiner's office. The body's been transported, and those insects have exited the area. That's why you need to do your collections at the scene, because you know maggots were responsible for removing this tissue, but now you have very few to collect. Same with animals. So this is the ones that you'll see at the scene, and if this animal was transported for a post-mortem exam, most all this colonization probably wouldn't make it unless you're very careful to try to keep it with you or in the body bag, in the transport pouch, trash bag, whatever you can use. But what's also important to us as entomologists is their location. And if we get them in a bag and the maggots are everywhere and we don't really know where they came from, we're somewhat limited. And what we're looking at here is just this head down progression that's the same on humans and animals. 350 million years, they go to the head first and they progress posterior. Unless there's trauma, then trauma may reverse that pattern entirely. So you don't need them all. You need maybe about 100 or so from each area of colonization. So you'd always want to make a collection from the natural openings on the head, the anal and genital area, and a sample collection from the extremities. This leg is intact. This leg is completely gone. There's the femur right there. So why are these legs decomposing so differently? Well, that answer is trauma, of course. So maybe these insects arrive first. So we could do an age comparison between the legs. The other thing is, why are these maggots out here? They're not really interested in the body. So is there something else out here that they are interested in? Or are these maggots older and are leaving the body like they are kind of genetically programmed to do? So I make a collection here as well. Again, about 100 from each. You want to put them in alcohol. Isopropyl alcohol is fine. Ethanol, ethyl alcohol, if you have it, is better. But you want to preserve some at the scene so their biological clock stops. And you also want to keep some alive. But the whole collection procedure is a little bit beyond the scope of this lecture. But if you have any questions, you can email me. I can send you a stepwise collection list along with equipment. So fine enough. The other thing you have to worry about with animals is these insects also really like to deposit eggs in the folds of skin. So in animals, maybe under a collar, where the legs meet the body, folds in the tail, that's where you really want to collect. Now, again, these maggots can't penetrate unbroken human or animal skin, but it's still a biological indicator that you can use. And if you see these maggots in folds of skin, certainly should collect them. It can be important. And I talked about hair. Female flies like to crawl through hair. They will deposit their eggs in hair. Here's the deal with that, though. You see these eggs are oriented along the hair shaft. It's really difficult to extract them because there's a bit of cementum on these eggs, and when they tend to dry out, they tend to stick to whatever they're on. So if you try to pick them out of hair, you're probably just going to kill your evidence. So I always keep a little straight razor with me, and I try to shave the hair off and just collect the eggs with the hair shaft. Now, you should make sure you have permission from law enforcement or your pathologist before you do that. Take a picture of the area before, take a picture after. But the reason I tell you to do that is because you're probably just going to destroy your evidence if you try to pick them out of the hair. And there they are in an animal. So you can see how completely the hair coat can be infested with eggs on that. And like I say, you can try to pick them off, but you're probably going to kill most of them. So it's best just to use a little razor blade and give the animal a little haircut in one spot. Now, here we go. So fetid fur. There are insects who will feed on urine-soaked fur or excrement-soaked fur. Maggots do not have teeth. They have a pair of mouth hooks, and maggots basically secrete a digestive enzyme. They tend to liquefy their food a little bit, and then they kind of rake it into their esophagus. So what happens is the flies are attracted to the excrement in the fur. The maggots will eat that. They will tend to liquefy that excrement, And if that solution, that maggot saliva along with the excrement is in contact with the skin of an animal for a long time, and also eventually will develop. And then that will get a little bit necrotic, and then that will attract other species of flies. So it's very important for you to make sure that your hair collections actually properly from the hair are kept separately from the ones that are from the tissues themselves, because there's going to be an age difference in those maggots, probably going to be a species difference as well. And that species difference and age difference can help us tell you how long that animal may have been without adequate medical care before it died, or how long the fur was fetid before these ulcerous wounds developed. We can give a lot more information in these situations if you keep your collection separate and document your collection well with photography. If you mix them all up, we'll still be able to age what's there, but we won't be able to shed enough information into this is you would like to have. Animal cases. People often will put animals in trash bags. They dump them in the woods, side of the road, in aquatic environments. So plastic is a barrier to these flies. They have a spongy mouth part. They really don't have teeth. They can't chew through anything. Beetles and their larvae can. So even really thin layers of plastic are a barrier. And this was actually double bagged. What you see on this white are the fly eggs right around the knot. So it was double bagged, double knotted, but not tight enough to so that there was no air exchange. So flies knew there was something dead in this because they could smell the odors of decomposition. They got as close as they could. They deposited their eggs. In this case, the maggots had not made their way through the knot and colonized the decomposing remains in the bag. But we could age what is on the outside of the bag and then tell law enforcement how long that bag has been exposed to the environment that these flies were in. So, like again, you can't give 100% of the picture, but you can give a lot of the picture. And sometimes just small pieces of the puzzle really help law enforcement. But just keep in mind, even really thin plastic, clear plastic, a painter's drop cloth, fist queen, is a formidable barrier to flies without chewing mouth parts. So you're also going to find some postmortem artifacts. So one of the postmortem artifacts you're going to see, you really should see more tissue loss anterior and more tissue preservation posterior. That's natural decomposition. Now, may this animal have had some head trauma? Certainly. That's why we have pathologists and some osteologists to help you examine those bones. But what it also is telling you is that these animals have no trauma anywhere else. The other thing you're going to see is you have fully developed maggots that are nearing their pupal stage and on their way out. And these white things back here are still eggs. So you still have later arriving flies, the flies that are later in succession, coming in and depositing their eggs. So you could have nearly a skeleton, but still find fly eggs. So you should collect those as well. Collect anything you see. You don't have to collect everything you see, but collect a representative sample of everything that you see. Can help us out a great deal. And then don't forget to look around in the surrounding area and collect these older because you want to know how long dead. We'll be able to age these, but these are older, and that extends your postmortem interval. And remember, they can crawl significant distances. Most of the time, they're just going to crawl till they seek shelter. It may only be a few feet, but I have found them, almost 50 yards away before. I just start near the body, start looking for maggots and larvae that are on their way out, and you just keep following that trail until I get to where that ends, and that's kind of the oldest maggots. And I just make a collection at various points along that trail. I note my distance and compass direction from the body, and then that's my collection. Even if you have skeletal remains, you can see you have far more tissue preservation posterior than you do anterior. That is expected. Now, may this animal have had some head trauma? Probably, maybe. Don't know. That's why you would turn to a pathologist or an osteologist to help you look for any trauma to that bone. But what you do know is the animal didn't have any trauma anywhere else. I mean, if it had trauma to the hindquarters or more along the abdomen, you wouldn't see this state of tissue preservation. So what you're looking at is pretty normal progression of larvae. So likely no trauma, or if there is trauma, it's just isolated to the head. So again, small portions of the puzzle. The other thing you want to look for is the dead grass that's around here. When these maggots wander away, they purge a lot of fluids from their body. It changes the soil pH very rapidly, and it kills vegetation. So you want to look in this area of dieback for older maggots or other maggots that are no longer on the body. And you want to follow that trail of vegetation dieback until it ends because that's where the larva went. They may go in an east-west transit because they're attracted to light. So you have the rising and setting sun if you're out with open horizons, but it may be upslope or downslope. The vegetation is a clue, and that's really entomology's tied to forensic botany as well. These same entomology indicators are aligning with the botanical indicators that are there, and it's all giving you a lot of information about your crime scene if you know what you're looking for. Soil will also give you a good indicator. What you see on this picture is you have a lot of tissue preservation in the head. There's no tissue gone there. Where you've lost your tissue is around the hips and top of the leg here. So you don't normally have a huge body opening in the top of the leg. And the other thing is what made them ignore the head? What made them ignore the head? There was trauma here when the first flies arrived. And you now know that as these maggots leave, they purge and it will kill the vegetation. It also stains the soil. So you have all of this soil staining right around the midpoint of the body. And if you look around the head, that soil is fine. It's not discolored. There's no decompositional fluid in it. So you focus your collections around here and you know that whatever defect happened here was at or about the time of death. Again, trauma, and they didn't crawl down the forearm or upper arm to get there. They can't penetrate unbroken skin, so you'd want to make a collection here. This is the person, of course, so that's a defensive wound. You can see a little bit of the hematoma in the bone there. Can't penetrate normally unbroken skin, so the only reason you have these little maggots there is because something broke that skin for them. So in a person, that's a defensive wound. And it's different for each species of animal. You have to really kind of, there's no standard rules for a decomposition pattern that is standard across all species. This is a pretty standard decomposition for a cow, but you saw the dog. Most of that tissue is gone except for the posterior, but cattle hide is very, very thick and very substantial. So this is from maggot feeding here. That's about all of the skeletalization you get from maggot feeding. Ears are gone because of vertebrate scavengers. Of course, the eyes are going to go away. And then you have some hair. The hair will slough off, but the hair will also be consumed by hide beetles as well. And I think I have another picture. Yeah. So all of this damage is from beetles. Maggots can't do it. I've had cases where, depending on location or shape, these holes in the hide were thought to be bullet wounds or shotgun blast. They're not. They're from hide beetles. And what you'd want to do is take a section of that tissue, look at it under a microscope, and you can see on the margins of the tissue that's just been chewed on. You can see the dentate patterns of the beetles that made it. And same for the hair. But this is about all of, just right around the muzzles, about all of the decomposition you're going to get from maggots. Everything else is going to be due to vertebrate scavenging, and you have all these weirder post-mortem artifacts that may look like a bullet wound from your buddies, the hide and skin beetles that come in much later. And then you may have something that is not explainable by insect activity at all. This is actually done by a person. A cow's tongue was removed. So why are people doing this to cows? We're not sure, but some cattle mutilation cases that go on, you probably may have been involved in some. Not really explainable as to what groups are doing this or why, but we've I always have questions of, is this a natural decomposition pattern or is this something human induced? And most of the time it's just natural, but we have come across numerous cases that are actually human induced. This is of course natural. This was a case that the farmer insisted that this animal was alive 24 hours prior. Said that the animal had been drained of its blood, its organs had been removed. So it sounded really interesting to us, so we went down to check it out. True, not much blood left and the organs were gone, but this is not due to an alien abduction. This is typical vertebrate scavenging. We got canine DNA off the end of the ribs. The farmer was really very concerned about the tearing of the skin. He didn't think that was natural, but if you've been around predator attacks on animals much, you know that the skin tears pretty much along its Langer lines, the fibers of the tissue, and it can be very, very straight. What you really want to do is look at some of that hair under a microscope and see if the hair is cut. If you're trying to cut into an animal with something that's really razor sharp, you're going to cut some of those hair shafts. But the hair shafts naturally not being cut is good proof that it's natural tearing. But so is getting some canine DNA off those same tissues. And look at the vegetation. That's what gave me my clue, is this vegetation dieback. That's from the maggot exodus. So this animal had been dead 7 days. not in any way, shape, or form was alive just 24 hours prior. I guess it was just a case of mistaken identity on the farmer's behalf. So I have said that these maggots will feed and then leave the body and complete their life cycle elsewhere. So there's exceptions to every rule. And the exception to the rule is there are a few species on animals well, there's a few species of flies that when they get on an animal, if that animal has long enough fur and thick enough fur, they will complete their entire life cycle on the animal itself. So what you're seeing here are those pupae that would normally be distributed out in the environment. These pupae have hatched. So you'll just find these empty pupal cases in the animal's hide or fur. And that's normal. And it's actually a way that kind of preserves our evidence. It's much easier to come across when you have that. But these insects are more typical in cooler environments, really dark, shady locations. So fortunately or unfortunately, you will encounter the species a good bit in hoarder houses. So they do not often distribute themselves that far. When animals are buried, it is not unusual to have insects on buried remains, but there is a question to be answered. Are the insects that you recover on the buried remains, are they the type of insects that can dig, or are they the type of insects that do not have the ability to dig? And if you find insects that do not have the ability to dig on a gravesite, you know that body was colonized before it went into the hole. And then we can, of course, age them and give you a timeline. And if it's the ones that can dig, then we can at least tell you probably how long that body has been in the hole. And if you find both, we add the two timelines together and we might come up with a fairly good post-mortem interval estimation for you on those. But they can dig pretty effectively. The thing is most burials are really pretty shallow. It's hard to dig. Criminals are lazy. So they're pretty readily colonized by the species that can dig. The thing that's important is we just need some pictures of the site before you start your excavation to be able to prove that the animal carcass was completely buried and no part of it was exposed before you start to dig, and that helps us prove the validity of the species that you recover and why they're there. Hopefully all that makes sense. People burn things. They burn animals, they burn humans. It's an attempt to rid the evidence. It is extremely difficult to burn all of the tissue off of a human or a large animal. And what happens is when it's burned, the proteins change, right? That's why you cook it. So the areas where the tissue is charred, the insects do not recognize it as a food source. And you do have a lot of tissue loss. But often you find not too deep under all that tissue that doesn't have a thermal effect. And that's colonized. So we can still give you a timeline because it'll probably be colonized. Your colonization pattern's off because there's now all these other points of access. But as soon as the body cools below about 100 degrees Fahrenheit, it'll probably be colonized again. You could probably find insects. So recolonization after a fire, not uncommon. In aquatic environments, remember, the water column itself is an environment. So in remains that are in an aquatic environment, you have two things. This is a person floating here. The part of the body that is above the water will be colonized by terrestrial insects, as if it was on land the whole time. And the part that is in the water will be colonized by aquatic insects. Some aquatic insects will feed on the tissues of the body, and others just gravitate to the body because of something new in their environment. I'll talk about that a little bit more. But you should make two collections. One from the parts of the body that was exposed to the air, and one under the water column. Now, here's where it matters. These insects that will colonize objects in the water, some of them will feed on the tissues of the body, be it human or animal, but most don't. Most just like to gravitate towards it because of something that is new in their neighborhood. So the stuff on the hood of this truck looks like silt, something you may want to scrape off so you can get the VIN number to figure out who owned this truck. That's your evidence. If you look closely, it's not silt. It's these little tubes that are made by aquatic insects. These tubes are different than those. The aquatic insect lives in those tubes. They develop these tubes at different times of the year. The tubes are different. If you're in sandy environments, they'll be made out of sand. They're just made out of whatever they can get out of the water column. In rocky creeks, they're made out of small pebbles. In forested environments, they're made out of leaves and twigs. So that's what they're living in. And they just filter the water for their food. So they gravitate towards things. So if an animal in a carrier has been thrown into a pond, they will colonize that animal the same rate they would the carrier, the collar that may be there. So it gives you what we call an aquatic submergence interval. So if you want to know how long something has been underwater, maybe it's the cat in the carrier that was dumped in the retention pond. We need that cat carrier. We need the cat itself, but we really need that cat carrier too. And then keep it wet, keep it in some of the water that it came out of. And an aquatic entomologist, an aquatic forensic entomologist, can tell you how long it's been in the water. So that's really the only way to get submergence intervals on a lot of evidence. So it doesn't matter if it's the tissues of the dead body, plastics, glass, or metal, it's all going to be colonized at the same rate. So when you're dealing with a case in an aquatic situation, you really need to take time and look to see if you see these little houses, these structures that these aquatic insects make, and have it analyzed. So ants, it's important to document ants too, their presence. Ants can haul off maggots, they eat fly eggs. So ants will keep a body clean of incoming fly eggs and maggots for a period of time, usually days, maybe 3 days. So if you see a lot of ants, you don't document it and tell the entomologist, they're probably going to be a little off. But here's the type of damage that ants will do to humans and animals. I just use this person here because it's easier to see the damage to the skin because of the lack of fur. Ant damage to humans and animals always starts out as little round pock marks. And that's what usually triggers the investigation because it looks like a pattern injury or some sort of an instrument used to burn the individual, or maybe even some sort of a caustic chemical splash. It is none. That's how the ants start. And as more ants come into the foraging mix, it gets more irregular. So we've had an adult human kind of devoid of its outer skin in about 24 hours just from ant activity. So of course, remove the skin of an animal much more quickly. And they don't eat hairs. They just tend to feed around hair. And they just remove the skin. But they will create these interesting patterns. It will expose the vasculature, but you can see the hair shafts in these areas are still undamaged. So if you have an animal that has some actually patches of its epidermis missing, but the hair is still intact, it's probably not a caustic chemical. It's probably a result of ant scavenging. And there's the ants actually scavenging on an animal. They're feeding around the hair. The color change in the tissues is just due to a differential drying of the tissue. Nothing the ants are doing other than abrading that tissue itself. Roaches will do the same thing, except for the fact that roaches will eat hair. So if you also see hair missing in those areas, or hair, the shafts have been trimmed down to the same level as the tissue damage, it's probably from roaches. Two types of roaches will do it. That's the German cockroach. They like to be inside, like to come to light. They infest your house because you pay their heating and air conditioning bill. And then the American cockroach, which actually likes to live outside, and it comes inside to scavenge on your old pizza boxes that you've left out and didn't clean up after yourself when you went to bed. So the other thing that will happen, bees and wasps, particularly on very fresh bodies, gunshot wounds, stab wounds, they will come in, they will macerate tissue, and then they take it away as food for their larvae. So they will, in a very short period of time, make a very small caliber gunshot wound look like a very large caliber gunshot wound. And they may occur in the hundreds, if not thousands. You can see these in the background here. The only way to stop that is to put up a mechanical barrier. So in my little crime scene kit, I always keep a sterile sheet so I can break out the sterile sheet and throw the sheet over it to stop this type of evidence eradication if needed, and then get the body moved off scene as quickly as you can. Alterations of blood stains. We have fly specks. Flies will alter blood stains. None of these blood droplets that you see were produced at the commission of a crime. They're all transported there by flies. So you really need to do your blood stain analysis very cautiously if you suspect insect activity at the scene, because they certainly can alter what a spatter expert may have to say about the crime scene. This is on an animal, actually, so you can see how these little droplets have dried and skeletalized, just like any other blood droplet would. So it can be confusing. So if you see fly activity and flies creating these types of stains on remote objects or on the body itself, it should be photographed and documented. And of course, fleas. You're all familiar with fleas. Fleas will, of course, pass undigested blood as a food source for their larvae. But this can wick into a surface and look like small, very 1 millimeter or less droplets, and mimics a very high, something moving with great speed and impacting blood, or something putting a force behind blood to make it move at a great speed and kind of vaporizing it a bit. All fleas just doing their thing, and it will test positive for the DNA of whatever the fleas fed on, by the way. So keep in mind those insect alterations to blood stains. So I wanted to leave about 10 minutes for some questions for the hour I had. I went over just a little bit, but I will stop share. And if someone has been managing our chat, I'll try to answer some questions for everyone.
Yes, we had a bunch of questions about the forensic entomology certification. There seems to be in person on the website, and they wanted to know when they updated that spreadsheet and if there are any online options for people to get that certification.
Yeah, so there are no online options. We want it to be in person. So you have to do the workshop in person. However, and we used to do the testing right after the workshop while it was still fresh in your mind, but we are now moving to like an online testing option. So if you do the workshop and need to catch a plane and gone, you can, test remotely later. So yeah, we are working on that, but yes, you do have to be in person for one of the approved workshops. There aren't too many approved workshops at the moment because it's kind of a new thing for us, but we are starting new workshops. And I don't think the dates are posted yet, but I'm going to be doing a workshop out in Texas in October that would qualify for the certification. So if anybody wants to work with us in person for 3 days out in Texas in October, email me at my email address that I put out, and we'll send you the information and registration details once the class is actually scheduled, and I will see you in Texas.
How fun. Someone had a question about what do you put your specimens in whenever you collect them to maintain the integrity?
So the preserved specimens, yes, that we're talking about.
Yes.
Yeah, like I said, isopropyl alcohol. Ethanol is best because it has less water in. Like 80% ethanol is probably the best thing you can find. If you're desperate and have to hit a Walgreens or CVS or Dollar General, and they have the 70% isopropyl, that will also work. This is what you have to keep in mind, though. There is preservation and fixing, Fixing. If you drop a maggot in alcohol, it's not going to be preserved for long because it is not fixed. You have to kill the bacteria in that and fix some of the proteins. You can fix by chemical and heat. Long story short, if you drop them in alcohol, make sure you get them sent to an entomologist as quickly as possible, or make contact with an entomologist and say, hey, I've got these maggots and I just put them in alcohol and I hear that I need to do something else with them, and then let an entomologist step you through it. If they're fixed and then preserved, they'll be good for 100 years or more. If you don't fix them, you just put them in an isopropyl, you put them in your evidence room, and then 2 months later you think, oh, I got to ship these out. They're probably going to be decomposed in that alcohol. So dropping them into alcohol does not make permanent preservation.
Excellent. They would like to know your email address again, but we can also add that to the survey sheet that comes out after the coursework, so everybody will receive that.
Yes. And if you want, I can give you like the scene checklist forms. You can send that out to the group that has registered, so they have them. I'm not protective of those. I try to get them out to as many people as possible.
That'd be amazing. We'll send it as an attachment.
Yes.
All right. We had someone ask about what does it mean whenever there is a lack of bugs at the scene? They had a dog and they assumed time of death was 72 hours prior, but there was no evidence of bugs on the dog.
It depends. I would have to really see pictures, right? I mean, because you got to look for mechanical barriers with screens intact, windows open, doors closed. So it does not lack of bugs inside without any information on ambient temperatures, the condition of the structure. It would be hard to relate it to a post-mortem interval. But I mean, something dead inside 72 hours is unusual. I think I see it now. Yeah, something dead inside 72 hours passes. Would it be unusual to not have any insects on it? No, not incredibly unusual. But if it's in the summer and the windows are open and you've got an environment that is somewhat rural, and that's about the time when you would expect to see them show up normally.
Out of their own curiosity, how did you decide to get into this line of work, and what schooling did you complete, and how long did it take?
I grew up on a farm, so I was always interested in entomology. I was a straight C student in high school. So when I graduated high school, I promised myself I would never set foot in a classroom again. But then after working as a landscaper and as a parts manager for General Motors, I thought, maybe I need to go to college. So the day I went over to the University of Florida to talk to the undergraduate coordinator was the same day the Gainesville Sun published an article on forensic entomology, and it detailed the school's medical and veterinary entomologist. And I was sitting talking to the graduate coordinator, and I told him why I was interested, because I was interested in forensics and also wanted to do entomology. They flipped the newspaper over and it says, kind of sounds like you want to do this. I'm like, yes. And I said, well, that guy they're talking about in this article is 2 doors down and he's sitting in his office. You want to go talk to him? So I did. And when I left there that day, I had a job in his lab. I did my bachelor's, I did my master's, I did my PhD. And 11 years later, I was done with education.
Oh, wow. We have about 6 more questions. I don't know how long you have. Do you want to do?
As long as you do.
Okay. Let's everybody hang tight then. Ashley asks, don't fleas leave the body when the animal is deceased?
Yeah, great question. Yeah, when it starts to cool off, there's no blood pressure. I mean, the fleas have a little a pump in their cephaloskeleton, but it can't pump well. So when blood pressure tends to cease and it cools off, fleas will start to leave, lice start to leave. Mosquitoes really won't feed on a dead body because there's no blood pressure there. So yes, they like to leave. Ticks do too. Everything seems to realize it's dead and is no longer any good.
Perfect. All right. Nichelle is wondering if you've ever seen slugs on decomposing bodies before and how they affect decomposition.
Slugs?
Slugs.
I've seen slugs, had cases with slugs, but we're not able to use them for a time frame. And the little bit of tissue alteration that they do with, their little raspy mouth part is not enough to alter decomposition from what I have seen.
Jody asks.
Rice is jumping maggots, by the way. I see that one.
And there's also, I don't know if you've been keeping up with the chat, a lot of questions about how to work around meal prepping without rice involved.
Yeah, I make sure we don't have any dishes with rice at our week-long workshops. So yeah. Yes, there is a meal prepping factor there. The thing I have difficulty with now is pork, because I've done so much research on dead pigs. Every time I smell pork, I just think of my research. So I have to lay off the pork chops for a while.
Definitely understandable. All right, Jody asked, after a maggot hatches, how long until it becomes a fly? And there's also a tie-in with another, do you have a timeline cheat sheet of decomposition, the life cycles, all of that?
Do not have a cheat sheet. It's impossible. Each species is going to develop at its a different rate, and then that rate is impacted by temperature. So they don't age like we do. When it's cold, they age very slowly. When it's hot, they age very fast. So it's an entomologist can look at a maggot. We may be able to tell you the species from a picture. We may be able to tell you the life stage, but we can't tell you how old it is unless we also know temperature. Which is why we don't really have any cheat sheets, because aging a maggot actually gets really complicated. So you do not need an entomologist at your scene to be able to collect and document these organisms. You do need an entomologist to be able to age them for you. And that said, I have to say that yes, we do have a board certification. There are board certified forensic entomologists, but many entomologists who are not board certified can age and time maggots for you. So that said, a local museum may have entomologists, your local college or university, agricultural extension service. You may very well be able to find a PhD entomologist who can take a maggot, identify and age it for you, and not be board certified. And I personally think that's fine. The non-board certified entomologist may be a little hesitant to go to court because they don't want to be attacked in court. But, we could always make contact with them and help them with their report, or take some of their initial data and write up our report on top of that and go testify, from their initial reports. There's all sorts of ways for you to get help at a scene from entomologists who are not necessarily board certified.
Excellent. And just last question, what part of Texas for your 3-day course coming up?
We do it with Texas A&M, so College Station's probably where we're going to base it out of. like I say, we're picking October. We're trying to find a facility and dates. We don't want to do it any sooner than October because of the heat, and we're trying to get it done before the Thanksgiving holidays hit. So in the next couple of weeks, we'll have some dates. I'll be able to send it to the group if you're interested.
Excellent. And with that, Jerica, would you like to send us off today?
Yes, thank you so much. That was incredible, incredibly gross at a couple of times, but incredible. So yeah, wow, thank you so much. I just want to put a quick plug out there. So NACA does have an ACO3, which is veterinary forensics focused. A lot of the cool things that were shown and mentioned are also part of this ACO3 program, which is in conjunction with the University of Florida. We have done 2 cohorts. We are currently in revision of the program to make some additional tweaks and things that we've learned along the way. So be looking out for us to release our next course. We're looking at probably 2026 at the moment, but keep an eye on our website and our socials. We will send it out to members first as well. So sign up if you haven't signed up yet. And yeah, it's very cool. 3 days in Florida at the University of Florida in Gainesville. We limited at 40, so you get some really in-depth discussion and you get to meet some really cool people all doing the same things. So be on the lookout for that. And again, thank you, Dr. Byrd. That was incredible. And we will see you all next month.
Thank you, everybody.
Thank you so much. Have a wonderful day.